The second major source of energy for humans or most animals is fat. Now, fats for a very long time have had a really bad rap. Okay? People for a very, very long time have talked about staying away from fats. Don't consume fats in your diet. It's bad for you. It's actually not the case. Okay? Yes, obviously, if you're consuming a lot of a specific type of fat, it's not that great for you. But sugar, a diet high in sugar actually poses more problems health-wise than a diet high in fat. Okay? Now, when we talk about fats, just like in carbohydrates, there's different types of fats. If you look at page 23 of your iBook, you'll notice that there is a glucose molecule right next to a fatty acid. So, when we talk about the size of the molecule, which one's bigger? The fatty acid's a lot bigger. Look at how many carbons it has in it. Holy moly. That's a lot. Okay? Now, fats come in two basic shapes. We have what we call saturated fats and what we call unsaturated fats. When we talk about saturated versus unsaturated fats, that has everything to do with their chemical structure. So on that page, on page 23, you have the chemical structure of two different molecules. You have the chemical structure of a glucose molecule, and if you count all of those little bars there, every time there's a little cross or a meeting, that is a carbon. So there's 6 carbons in a glucose versus, there can be up to hundreds of carbons in one fatty acid. Okay? And when we talk about something being saturated, what does the word saturated make you think of?
Full.
It makes you think of full, like a sponge is saturated with water. It cannot absorb any more water. Okay, well, saturated fats have their carbons, and each of their carbons has 4 bonds to it. Okay, every one carbon has 4 bonds coming out of it. Whether it's bound to another carbon or bound to oxygens or hydrogens, it doesn't matter. And if you look at that saturated fat on page 23 of your iBook, you'll notice that it looks like this ginormous chain of carbons with hydrogens attached to it. Every carbon has 4 things bound to it. Okay? Every carbon. And it creates this sense of fullness that molecule cannot take any more hydrogens. It is loaded with hydrogens. It's the most it can get. It is saturated. Now, saturated fatty acids are interesting because when we're looking at the image of the actual molecule, a saturated fatty acid is a linear molecule. It has no hooks or loops or circles in it. It is flat as a pancake. Okay? When you actually store fatty acids into fat cells, if you've got a high amount of saturated fat, they stack really nice and easy, one on top of the other. You can put a lot of fat, saturated fat chains into a fat cell. Okay? A lot of them. And the more fats you have in a fat cell, the longer it takes to burn that fat cell off, because you've got to get through every one of those saturated molecules that is storing so much energy. Okay? Unsaturated fats are a little bit different. An unsaturated fat is exactly that. It is not saturated. It is not loaded with hydrogens. And we can identify unsaturated fats, okay, by the actual shape that they take on, because every time that you have an unsaturated fat, you have something called a double bond. Okay? which means that it is a crook somewhere in the molecule that is causing the molecule to not have as many hydrogens as it otherwise would. And if you look at page 24 of your iBook, saturated versus unsaturated fats, you will notice that a saturated fatty acid is nice and linear, whereas an unsaturated fatty acid will have what we call crooks in it. Okay? It makes it not as easy to stack. And if you have a lot more unsaturated fatty acids inside a fat cell, they take up more space. So there's less actual individual fatty acids in that one fat cell, which means when you're trying to burn off that fat, you empty the store of fat chains in there much more quickly because there's less of them. So when you're trying to lose weight, you're trying to get rid of these fat stores, these fat cells on your body, you've got to burn that energy off. Okay? So we just talked about carbohydrates. And somebody who is trying to lose weight will first have to burn through their day's supply of carbohydrates. So when you go to the gym, does anybody go to the gym here? Has anybody ever heard that when you're doing cardio at the gym, you should always do it for at least 15 to 20 minutes? Okay, well, the reason they talk about that is, it is good to exercise your heart and all that, but from purely a weight loss point of view, it takes you about 15 minutes to burn through your store of carbohydrates, 15 to 20 minutes, and anything on top of that, then you're attacking your saturated, or well, actually not saturated, your fat stores. So if you want to lose weight, you've got to burn through your carbohydrates, which go first because they're easy to burn, and then your body attacks or gets energy from its stored bank of energy, which is your fat cells. When we talk about unsaturated fats are good for you. Okay? They're really good for you. And when you're looking at a food label, if something says that it has, 8 grams of fat in it, by law in Canada, they must state how much of that total 8 grams of fat is saturated fat. And they must also state how much is what we call trans fat. So the rest is assumed that it is unsaturated fat. Okay? Now, trans fats, on the other side, are also an unsaturated fat. But a trans fat is man-made. Okay? It is not a natural thing. It is something that we have chemically devised to make food taste better. And it's usually found in junk food or fast food.
McDonald's, chips.
Yeah, all that jazz. All those store-bought cookies and store-bought little cakes and things like that. Trans fats. Okay, you'll often find it in store-bought icings and things like that. Okay? Now, what's really frustrating about a trans fat is trans fats will have one double bond in them. Okay? And it will cause that fat to have a little crook. One tiny little crook. Okay? And in that crook is so tiny that it actually makes the fat molecule look like this. Okay? Is this molecule, this linear, more or less molecule, any different really than these guys, than the saturated fats? No, it's not really different. So these two stack like pancakes. So when we have a lot of trans fats, we're storing those fats in our fat cells, and we can store a lot of them. So very similar to saturated fats, it takes a long time for them to actually break down because there's more of them in a cell. Okay? And what I mean by that is if I've got these two cells here, okay, these are my fat cells, and in one fat cell I've got a bunch of these, okay, molecules, And then here I've got a higher concentration of, unsaturated fats. Which of these cells is going to get burned off and used up more quickly? Okay, if this is mostly trans and saturated and this is mostly unsaturated, this one's, we're going to get rid of it more quickly. Now, I'm not saying that in the human body, all saturated fats go into one fat cell only. No, it's a big mix-up. But the more saturated and trans fats you have in your diet, the more you're going to store. Okay, that it's as simple as that. So eating things like avocados and stuff like that have natural fats in them, they have unsaturated fats in them. There are very few plant-based types of fat that have saturated fat in them. The only one that's really bad is coconut. Okay, coconut has a tremendous amount of natural saturated fat in it. Okay, but eating that every once in a while is not a bad thing. Okay, there's a lot of evidence in today's day and age. Now, when I taught this about, 10 years ago, it was like, oh, stay away from fat. Fat's not good for you. But a lot of the research is showing right now that fat is not a problem. We actually do need fat because in addition to being a slow burning energy and it provides us with the rest of our energy, fat is a wonderful insulator. So even a quote-unquote skinny person has natural body fat on them. Your fat actually surrounds your muscles, and then your skin goes over top of that, and it acts as a protectant. Okay? Your butt cheeks and your breasts have a lot of fat in them. For your butt cheeks, that's insulation. So that's so you're not sitting on your actual hip bones. Okay, that's very painful. Okay, you've got a lot of nerves there. You would damage those bones. So fat is an insulator, but it's also a slow burning form of energy. Okay? So the difference between trans fats and unsaturated fats, a trans fat is an unsaturated fat, but it's not a natural one. And when we actually draw out a trans fat, the way that the molecule is actually formed is that the double bond here forms such a small kink that it's almost unnoticeable. So it's practically a linear molecule, just like a saturated fat. Okay? Whereas most natural unsaturated fats, okay, like you've got saturated and unsaturated fats in your book, and that is on page 24. Okay, you see things like acid, the fats that are in nuts. Okay, so peanuts and things like that have a lot of arachidonic acid. Oleic acid is a big one. Linolenic acid. Okay, linoleic acid. They have really big kinks in them, much more so than a man-made trans fat. So these guys take up more space. They're easier to break down.